Today I'm going to prove the trigonomic identity of cotangent of theta plus tangent of theta to the second power is equal to cosecant squared of theta times secant squared of theta using trigonomic manipulatives. Each trig manipulative represents a different trigonomic function, and each has its own unique pattern on the top and bottom, which allows it to combine with other functions to make new functions with the same pattern. The first step in proving this trigonomic identity is to simplify everything into sines and cosines. This will make simplifying a lot easier. So, using the definitions of the trig identities themselves, I know that cotangent of theta equals cosine of theta over sine of theta, and I know that tangent of theta equals sine of theta over cosine of theta. So I can put them both in place of cotangent of theta and tangent of theta. Notice in both functions how the sines and cosines that are together match the patterns of the original functions of tangent of theta and cotangent theta. The next step is to add the two fractions together. Since you can only add fractions with common denominators, I will need to get both denominators the same. And to do so, I will need to multiply each fraction by a former 1, which in this case will be either cosine of theta over cosine of theta or sine of theta over sine of theta. On the left fraction, I will multiply top and bottom by cosine of theta. On the right fraction, I will multiply both top and bottom by sine of theta. Now this can be simplified. On the top, cosine of theta times cosine of theta equals cosine squared of theta. Notice how the squared function is twice as wide as the original. This is because it is two of these functions being multiplied together. And on the right, sine of theta times sine of theta can just be simplified to sine squared of theta. Since the denominators in each fraction do not have any like terms, I can just keep them as they are. Now that both fractions have like denominators, I can add the fractions together. The numerator will just be added together, and that is represented by a plus sign. The denominator can just be combined to a single term, cosine of theta times sine of theta. Next, using the Pythagorean identity, I know that sine squared of theta times cosine squared of theta equals 1. So I can replace the sine squared of theta times cosine squared of theta with a 1 in the numerator. That would simplify the identity to 1 over cosine of theta times sine of theta all to the second power. The next step in solving this identity is to square the function of 1 over cosine of theta times sine of theta. So I would multiply 1 over cosine of theta times sine of theta by 1 over cosine of theta times sine of theta. Now I can just multiply these fractions straight across. 1 times 1 equals 1, and cosine of theta times sine of theta times cosine of theta times sine of theta equals cosine squared of theta times sine squared of theta. The final step in solving this identity is to use the reciprocal identity. The reciprocal identity proves that every function has an inverse, which is found by switching the numerator and denominator around. For example, secant squared of theta is equal to 1 over cosine squared of theta, and cosecant squared of theta is equal to 1 over sine squared of theta. So using that example, I know that 1 over cosine squared of theta times sine squared of theta is just equal to cosecant squared of theta times secant squared of theta. I have successfully proved the trig identity of cotangent of theta plus tangent of theta, all squared, equals cosecant squared of theta times secant squared of theta, using trigonomic manipulatives and other trigonomic identities. Thank you for watching.